Today's lesson, Multiplication Properties, is Lesson 3 and Topic 1 of 4th grade Envision. For this lesson, we will try to answer the following question. How can properties help you multiply? Let's begin with the vocabulary for this lesson. The vocabulary for this lesson are the following: property, commutative property, identity property, and zero property. You will need to know all three properties for this lesson. Also note that a property is a rule that works and helps you to do math. So let's begin with interactive learning. Find two ways to arrange 10 desks in equal rows and draw the arrays to show each way. Then write a number sentence to represent each array. So let's start. I know I have 10 desks, and so I'm going to just draw a square. A square will represent my desk. I need to make sure that they're in equal rows, and I need to make sure they are drawn in an array. So that's what I'm going to do. Let's see. 1, 2, 3, 4, 5. There's 5 desks. If I draw 5 more, I'll get 10. 5, 6, 7, 8, 9, 10. There are my 10 desks. There's 1 row and there's 2 rows. And in each row, there are 5. So I have 2 rows of 5. So I did the first part of the directions. I drew the array. Now I need to write a number sentence to represent this array. So 2 times 5 equals 10. 2 is a factor, 5 is a factor, and 10 is the product. Now, is there another way that I can draw my desks so that they still are in equal columns and rows? All right, so I have 10 desks. Let's see, how else can I draw this? Let's see. All right, I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10, but in this case, I don't have 2 rows. I have 1, 2, 3, 4, 5 rows. In this case, I have 5 rows, and I have 2 in each row. So in this case, I have 5 rows of 2, but that still equals 10. So let's see. In both arrays, I have 10. But in the pink array, I have 5 rows. In the red array, I have 2 rows. In the pink array, I have 2 columns. In the red array, I have 5 columns. You will notice that in my second number sentence, 5 is a factor and 2 is a factor. So even if I switch my factors, I will still have the same product. This is an example of the commutative property of multiplication. You can write it this way. 2 times 5 equals 5 times 2. You will have the same product either way. They are equal to each other. So the commutative property means that no matter which way you multiply your 2 factors, you will end up with the same product. Let's look at another example. Taryn wants to arrange 15 pictures on his wall in equal rows. He says he can only make 3 rows of 5 pictures. Is he correct? So what we need to do is we need to try to come up with a different arrangement for the 15 pictures other than 3 rows of 5. So let's see, I know I have 15. So let's see, I'm Okay, so, well, I can put the pictures on my wall this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, that's a long row of pictures. That's one row, though. One row. That's one long row of 15. One long row of 15. 1 times 15 equals 15. Can I do it another way? Sure. Let's try another way. What if I just flipped, instead of doing one row, can I do one column? Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Oh, we're right at the bottom with our 15, way down here. Okay, so we have 15 rows. We have 15 rows. Doing this horizontally. But we have one column. One column going down. So that's 15 times 1 equals 15. This is also an example of another property. This is called the identity property, which means anything times 1 is that same number. So 15 times 1 is 15. 1 times 15 is 15. What if I multiplied 6 times 1? 6 times 1 would still be 6. What if I multiplied 1 times 7? 1 times 7 would give me 7. These three are examples of the identity property. Anything times 1 is that same number. So let's look at another example. Here you see groups of soccer balls. In this first set, you will see that there are 3 groups. 3 groups of 2, 6 balls in all. So I would write a number sentence for this as follows. 3 groups of 2 equals 6. Now, in the next picture, you'll see that instead I have 2 groups. 2 groups of 3 is 6. Now, I've represented the product of 6 using 2 different multiplication sentences. Is this an example of the identity property or the commutative property? That's right, this is an example of the commutative property because I have the same 2 factors, and no matter which way I flip them, I still come up with the same product because 3 times 2 is equal to 2 times 3. We get the same total, the same product. So let's look at the following. What would complete this number sentence? 4 times 7 equals 7 times blank. What number do I need to put there to complete this number sentence? 4. That's right, because this is an example of the commutative property. Now let's look at number 6. I have 6 times 10 equals a number times 6. Now what number needs to go in the blank to complete this number sentence? That's right, 10, because this is an example of the commutative property. Now, you will complete the following, 19 through 26. And underneath each example, I would like you to put the property that this problem represents. For example, after you complete the number sentence for number 19, write the property that represents this number sentence right below it. And so on for all of the problems through 26. And you will be doing this in box 3 of your homework sheet. And in box 4 of your homework sheet, you will need to find out where you see things arranged in rows and stacks. And you're going to give 5 examples. If you have any questions or comments, you can add those into box 4, and we will go over them during tomorrow's lesson. Thank you, and have a good night.